Okay. Hello everyone. So in this video, I'll walk you through a complete HTTP log analysis project using pandas in Python. So we will be working with a real Apache server log dataset from July 1995 and performing structured analysis on a raw log data. Okay. So like this project is useful in a data engineering, data analysis, and like even in a machine learning interview preparation actually. So in step one, we are understanding the log format actually. So like each log entry follows the Apache command log. So before that we will just load the data from our local. Okay, so first for that we need a pandas library, so we will install the pandas library. Then we make an aliasing with pd, that is import pandas as pd, and we load the file and use a regular expression to load the data in a clean format. So for that we need a import re, that is regular expression, and import os. Okay, now this is the log pattern, this is file path, and this is the data where we saving. Then we are using the try and except loop here for the loading data, then converting into the data frame first of all, and some network error issue we have, so we'll just make this error in except block. Okay, so this is the data we have. So in this data we have a host column, then date time, that is timestamp, then method how we get, then this is the url, this is the protocol, and this is the status, and in the last column we have a size. Okay, so for example, local host, then this is time type 24th October 1994, this is date time, that is this is date, and this is time, that is like 113 for as 41, and this is the 0600. Method is a get, url is index.html, protocol is a http/1.1.0, status is 200, and size is 150. Okay, likewise. Now we will go through some basic analysis, that will check what is df.head, it contains first 5 rows, then df.tail, it contains last 5 rows, then df.info, it gives the information about each column, that is host contains non-null, this value is non-null count, and the data type is like this object data type, like date time is also data type object, then url also object, status is the integer format, and size is also in an integer format. Likewise, then df.describe gives us the basic statistics, summary statistics actually, which like column has a count, how many counts, what is the mean value, standard deviation, minimum value, what is the first quartile, that is 25%, then second quartile, then what is the third quartile, it is 75% of the data, and what is the maximum value. Okay, next we will check the df dot is null dot sum, that is if there is missing values or not. So in output we will get all the null zero values, so we can say that here we don't have any null values. Okay, next we will see the pass timestamp string into the date time object, like we are converting into the particular date time format, particular date time column. Okay, so here we can see the date time column is converted into the like in proper format actually. Next is we are extracting the file extension from the file name field, that is url dot string dot split. So split will do the splitting on a dot, and it will give the last actually last of your format, dot extension format. Okay, next is so for this we are using the regular expression to extract a structured field from the raw data. So then we convert the extracted data into the pandas data field. So after loading the data we perform proper cleaning, that converting into the particular timestamp to date time, then convert status code to the numeric, then convert byte size to the numeric code, then remove malformed entries, and then handling some missing values here. And we also like remove or we find which are the valid and invalid logs actually here. Okay, so this ensures our data set is clean and analysis ready purpose. Okay, in step 3, like we are doing the some analysis question actually. Now let's walk through the analysis task implementation in this project. So question first is we have to find that how many total log records actually. Okay, so for that we are using the for length function for the df, so which will give the value 664400 as like, and the return format is a integer. Okay, now like that, in that each line represents one request actually, so this gives us a overall traffic value. Now in second question we are finding the count of unique host, that is the distinct unique host actually. Okay, so this helps measures unique users or a system, and the return type is again in integer format. In question 3 we are finding the date wise unique file name counts, and for each date in July 1995 we count how many unique file names were requested, and we format the date as DDMMYY. For example, like 1st July 1995 or a 1st August 1995 likewise. Okay, so the result will be in the dictionary format, this key and value format. Okay, so this is mapping date to count actually. In question 4 we are finding a number of 404 responses actually. So we count how many requests resulted in a 404 not found error actually. So this will help identify broken links or a missing resources. So again we'll get here 0 because we don't have any request from the 404 port, and the return type is again integer. Now next question is we have a top 50 file names from with the 404 responses. So we count how many requests resulted in a 404 not found error. Okay, so this will help identify broken links or a missing resources. So for that we created a function, def function, that is top 50 404 file names, and we are getting the values that count. So the return type is again integer format. Okay, that is list tuple string integer. And on the next like question 5 we like finding this question 6 we are finding the top 50 file extension with 404 responses. For that purpose again we are created one def function, which is in the Python, and we just extract the file extension like HTML, GIF, JPG, and identify which extension caused the most 404 errors. Okay, so this helps understand what type of a content is failing, and the return type is list of tuples. Then in question 7, total bandwidth transferred per day, we assume the bytes. Here we assume the like bytes or we sum the bytes transferred per day during July 1995. So we exclude missing or invalid bytes values. So this helps measure daily server load and usage pattern. So return type is in the dictionary with date as a key and the total byte as a value, like this one. Okay, in the question 8 we are finding hourly request distribution. So for that again we are created one function that we extract the hour from the timestamp and count how many requests occur each hour from 0 to 23 likewise. So this helps in identify peak traffic values, and return type is a dictionary mapping hour to request count. Now in the question 9 we are finding the top 10 most requested file names. So we identify the most frequently requested file names regardless of status code. So this will help detect popular content, and return type is in the list and tuple format, likewise that's index.html, and this is the 104096. This is the format actually. Okay, next is in the last we are finding the HTTP response code distribution. So we count occurrences of each HTTP status code such as like 200, 404, 500 likewise. Okay, and the return type is again dictionary mapping status code to count, and in this way we are doing the analysis, and the result will be like 200. For the 200 we get these are the some like distribution HTTP distribution, that 566176 likewise. Okay, so here we can key concept demonstrated are this project demonstrate like log parsing using regular expression, then data cleaning and pre-processing, handling malfault entries, time-based analysis, frequency aggregation, then efficient like use of a pandas library, then real world data problem solving. So we get a conclusion from above project is that we transform raw unstructured server logs into the structured format inside using the Python pandas library. So this will demonstrate practical data engineering analytical skills. So if you find this is helpful project, you can go to like particular website, and thank you for the watching. Thank you.